Good afternoon, everyone. Welcome back to the third week of the second quarter. Our topic for this day is all about the basic terms in algebra and translation of verbal phrases to mathematical phrases and vice versa. But before that, may I present to you first our objectives for today's discussion. So at the end of this, you should be able to define related terms in algebra, illustrate related terms in algebra, differentiate related terms in algebra, and lastly, translate verbal phrases to mathematical phrases and vice versa. So, please familiarize the words or the terms that may I present to you, just like algebraic expression, constant, variable, exponent, and term, because this will be the helpful hint in order for you to solve our topic or to solve the given problem in our topic today. So, what is term or what is the term algebraic expression mean? So, it means that it is a group of terms separated by the plus or minus sign or the operations. We have the plus, minus, multiplication, and division. Next, let's define what is constant. When we talk about constant, it is a term or number with exact value. So that is a number. Constant is a number. Next, variable. Variable is any letter in the alphabet representing a known value, sometimes called a literal coefficient. So as you can see, variable is any letter. So that is in the letter in the alphabet. Next, let's proceed with the term exponent. So let's define what is exponent. Exponent tells how many times the base is used as a factor. So those number in the number written in the upper of another exponent, another constant rather, or variable. That is exponent. So as this lesson goes by, you will learn what is exponent. So let's define what is term. So a term is a constant or a variable or constants and variables multiplied together. So the number part of each term is called the numerical coefficient, while the variable or variables is or are called the literal coefficients. For the term 2x or 2yz, the numerical coefficient is 2, and the literal coefficients are y and z. So when we talk about coefficient or numerical coefficient, that is a number. When we talk about literal coefficient, that is a variable. So let's proceed. So there is an infinite number of values that can take the place of x and y. These letters are called variables. As I said while ago, those letters are called variables. So which remains unchanged is called constant. So number is constant. For example, the 5, that is constant. And variables are x and y because they are letters. Let's consider the expression given below. We have the 4x squared plus 3y and plus 2. So the numbers 4, 3, and 2 are constants since they are number. Then x and y are variables. So x squared, the number above the variable, is called exponent. So the number 2, the above number of x, that is called exponent. So that is 2. So the terms 4 squared, 2 cubed, and x to the fourth are called powers or exponents. So the number 2, 3, and 4 that are powers or exponents. So if we have the expressions 4 raised to 2, 2 cube, or x to the fourth, it can be read as follows. So you can read that the 4 squared or 4 to the second power or 4 squared. Next, we have 2 cube or 2 to the third power or 2 cube. Then x to the fourth power or x to the fourth. So that is how are you going to read the expressions. Algebraic expression can be classified according to the number of terms. So again, terms is separated by the plus, minus, and multiplication or division sign. So a polynomial is an algebraic expression which or where each term is a constant, a variable or a product of a constant and variable. The variable has a whole number, non-negative number exponent. A polynomial also can be a monomial, binomial, trinomial, or multinomial. So if we have the expressions given below in the diagram, then the second is the first term, the second term, and the third term. If we have the expression negative 5ab squared c cubed, so that is only a first term since there is no another plus or minus sign. So next we have 2x squared. At the same with negative 5ab squared c cubed. So it is only one term. Next we have negative 3a squared x. So that is only one term. So let's proceed with the fourth example. We have negative x squared y plus xy squared. So as you can see, there are now operations negative and positive. So that is two terms. So the first term there is negative x squared y and the second term is x y squared. So next, let's proceed with the fifth example. We have x plus 2y. So the same as the fourth example, it is consists of two terms. So the first term is x and the second term is 2y. So it's separated by the positive sign or plus sign. So number 6 example, that is negative a squared minus 4. So this expression is separated by the minus sign. So the first term is negative a squared and the second term is negative 4. So let's proceed with the next example or seventh example. We have negative a squared minus 4ab plus 2b squared. So as you can see, there are three terms. So the first term is involved negative a squared, the second term is negative 4ab, and the third term is positive 2b squared. So next expression, we have x squared plus 2x minus 3. So as you can see, there are another three terms. So the first term is the x squared, the second term is 2x, and the last term is negative 3. So last expression, we have xy plus 2x minus 3y. So the first term is xy, the second term is 2x, and the last term is negative 3y.
Take a look of a given polynomial or not. We have 7x squared. It satisfies the equation, so it is polynomial since the exponent is positive. Next, we have the expression 7x to the negative 2 power. So the exponent is negative, so it is not a polynomial. Next expression is 7 over x. There is a variable in the denominator, so this is not a polynomial. Last expression is square root of x cubed. The variable is inside the radical sign, so it is not a polynomial. Since polynomial consists only a positive exponent, so polynomial does not have negative exponent. The variable is not in the denominator, as well as it is not composed of radical sign. If the polynomial is in the standard form, terms are arranged in descending order of exponents. When we talk about descending, from the highest to lowest. The first term is called the leading term. The numerical coefficient of the leading term is called the leading coefficient. The degree of a polynomial in a single variable is the highest exponent of the variable among the terms. For polynomials with more than one variable, the degree of the polynomials is the highest sum of the exponents of the variables among the terms. So, of this, from the given y squared minus 2y plus 1, so the first term is y squared. So the degree of the term is 2 since the exponent is 2. The next term is negative 2y. The degree of this is 1 since it is only have a variable. If the variable does not consist of any exponent, so it is considered as 1. The exponent of it is considered as 1. Last term is 1, so the degree of the term is 0. Since the highest exponent of the polynomial y squared minus 2y plus 1 is 2, the degree of the polynomial is 2. You can also say that it is in the second degree trinomial since there are 3 terms, so that is why trinomial. Next example, we have 11d. The variable d has exponent of 1. Thus, degree of the polynomial 11d is 1. You can also say that it is in the first degree monomial, since monomial is composed of only one term. Let's take a look of another example. We have negative b, q, r. Each variable has an exponent of 1, that is, negative b1, q1, r1. The sum of their exponent is 3. Therefore, the degree of the polynomial is 3. You can also say that it is a third degree monomial since the exponent, the sum of the exponents rather are 3. So, you can read as third degree monomial. Another example, we have a to the fourth power minus 4a to the cube b plus 6a squared b squared minus 4ab cubed plus b to the fourth power. You can say that all the variables, if you add the sum, is 4. So you can say that the sum of the exponents of each term is 4. Therefore, the degree of the polynomial is 4. You can say that it is in the fourth degree polynomial since it is composed of more than 3 terms. Another example, we have negative qt plus 10 minus u to the fifth power v to the fourth power plus u to the fourth power v to the fifth power. In the polynomial, negative qv has a degree of 2, 10 has a degree of 0, negative u5, v4, and negative u4, v5 have a degree of 9. The highest of the sum of the exponents of the terms is 9. Therefore, the degree of the polynomial is 9. You can also say that it is in the 9th degree polynomial. Consider the trinomial 8x minus y plus 32. The three terms of the trinomial are 8x, negative y, and 32. 8x, 8 is the numerical coefficient of x, and x is the literal coefficient of 8. In the term negative y, the numerical coefficient is negative 1. The numerical coefficient of 1 can be written in a term since the term negative y means negative 1y. Terms with the same literal coefficients of the same degree are called similar terms, while the terms that have different literal coefficients and degree are called dissimilar terms. Always remember these two keywords, similar terms and dissimilar terms, because it will be helpful for you to solve or to add, subtract, multiply, or divide a polynomial. Here an example of similar terms. We have 2ab, 6ab, and negative ab. So never mind the constant, always take a look of the variable and as well as the exponent of the variable. Example of the similar terms, we have 2a, 3ab, and negative 5b. So as you can see, the difference between the similar terms and the similar terms, the similar terms example, they have the same variable and the degree or the term or the exponent of the variables are the same. While in the dissimilar terms, the given examples, there is only one variable for the first term, we have 2a and another two variables a and b. So they do not have the same number, or they do not have the same given variable. Always take note in determining similar and dissimilar terms, the numerical coefficient do not matter. Here are the kinds of polynomial according to its degree. We have the constant. When constant is a polynomial with the degree of 0. So the example is 3. We have linear. When we say linear, a polynomial of degree is 1. Then x plus 3. Quadratic, a polynomial of degree 2. X squared minus x plus 3. Cubic, a polynomial of degree of 3. We have 2x cubed minus 4x squared plus 3. Quartic, a polynomial of degree of 4. We have x to the 4th minus 3x plus 3. Quintic, a polynomial of degree of 5. 2x to the 5th power minus 4x to the 4th power minus 2x cubed plus 4. So always remember these kinds of a polynomial according to its degree. Now, the directions. Read and answer the following questions. Write your answer on your mathematics notebook. Which of the following is similar to the negative 2m to the 4th n cubed? Again, when we say similar terms, so always remember that the variables matter as well as the exponent of the variable. In the given, negative 2m, 4th, n cubed. So the variables are m and n. So in the choices, there are only two choices that compose of m and n variables. Then let's take a look with the exponent of m and n. For the m, that is 4. For the n, that is 3. So the answer is letter D. Number 2. Which of the following is dissimilar to the second term of the expression 2x cubed y minus x squared y cubed plus 5x y to the 4th minus 1? Again, we are looking for dissimilar term of the second term. So the second term is negative x squared y cubed. So if we are going to look for the choices, among the choices, only letter C is composed of x squared y squared. So the answer is letter C. Number 3. What is the exponential form of R, S, S, T, S, T, T, S, 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 S? So if the given is like this, always count the number or how many S are there. So we have 7. Then how many T are there? There are 3. How many R? Only 1. So the answer is letter B. R, S to the 7th power and T to the 3rd power. Which of the following represents an unknown numerical value? We have A, constant, B, terms, C, exponent, D, variable. So the answer is letter D, variable, because constant is fixed number. Terms are separated by the operations. Exponent is the number in the above of the given number or variable. So the answer is letter D, variable. Number 5. It is an algebra expression with many terms. Okay, the hint there is many terms. Binomial is only 2 terms. Polynomial, many terms. Monomial, only 1 terms. Trinomial, only 3 terms. Since we are looking for the expression with many terms, so the answer is letter B, polynomial. Next, we have translation of verbal phrases to mathematical phrases and vice versa. If we have here addition, subtraction, multiplication, 4 squared, division, square root of 2, twice, and 3. So we are going to connect the expression of this to the symbol of that. So we have the addition. So the symbol of this is here, while subtraction, then multiplication. After that, we have 4 squared. Then division, square root of 2, twice, and 3. I hope that you are ready to go forward with our lesson. From the quotation, we have read the words increase, decrease, multiply, and divide are some of the keywords used in translating verbal praise to mathematical praise. Here are more keywords that would indicate when to use the 4 fundamental operations. Always remember that in addition, the symbols is plus. Here are the keywords in addition. We have plus, increase by, added to, the sum of, more than, and total. While in subtraction, minus, decrease by, subtracted from, the difference of, less than, and diminished by. In the multiplication, we have times multiplied by the product of, twice, and thrice. In the division, we have divided by, ratio of, and the quotient of. So always remember this one because this is helpful in translating a math or in translating English phrase into mathematical phrases. Here an example of English phrase. We have 10 less a number. In mathematical phrase, the first term 10, that is 10. Then the symbol or the operations we are going to use, less. Less means minus. Then a number and any variable you can substitute is n or any variable you can choose. Then next given, we have 10 less than a number n. First term is 10 and the second term is number n. Another, we have less than. So the term than is a switch word, and in cases like this, the second term comes the first and the first term comes the last. So it will be n minus 10 because of the word than. Next, we have 20 more than a number x. The first term is 20 and the second term is x. Since there is a word than, so we can switch the places of the terms. Instead of 20 plus x, we will make that one as x plus 20. Next expression is a number n divided by 3. So the first term is number n. The operation we are going to use is divided by. Then the second term is 3. So n divided by 3 or n over 3. You can also read that one as the ratio of n over 3. What if we have the phrase, the difference of 3 and twice a number plus 1? Know that difference represents subtraction. Twice means multiplied by 2. And the number is a variable. The first term is 3 and the second term is twice a number plus 1. Hence, the second term is a group enclosed into parentheses to separate independent grouping. So we have another example, the difference of 3 and twice a number plus 1. So the first term there is 3 and the second term is, since the operation we are going to use is difference, so that is minus. The second term is a number plus 1, any variable plus 1. Since there is twice a number, so we have 2, then the variable, then plus 1. Next example, we have the quotient of thrice a number and 4. So the first term there is 3 thrice a number. The second term is 4. But the operation we are going to use is quotient of. So that is divided by. So 3n divided by 4. Remember, addition and multiplication are commutative. When we say commutative, that means Interchanging the place of the addends does not affect the sum, and interchanging the factors does not affect the product. Example, 7 plus a number. 7 plus x or x plus 7. The product of 5 and a number n. 5 times n or 5 times n or 5n or n 5. So in algebra, the letter x may not be used in multiplication because it will lead to confusion because x is also used as a variable. Instead, we can use a dot or parenthesis such as 5 times n. So practice this one. Translate each English phrase into mathematical phrases. Write your answer in the space provided. Number 1. The sum of 4 and a number. So the operation you are going to use is plus. So the first term is 4 and the second term is a number. So the answer is 4 plus n or any variable. 4 plus any variable. Number 2. 6 less than a number. So always remember that the word than is you are going to switch the places of the terms. Instead of 6 minus a number, you will use variable minus 6. Next, the product of m and a number. So just simply write m and or you are going to write m then enclose in the parentheses n. Number 4, the quotient of x and 7. Always remember, the operation you are going to use is quotient. So that is divide. So x divided by 7. Number 5, the sum of twice a number n and 6. So you are going to use the operation of addition since the word there is sum. Twice a number n, that is 2 and 2n. The second term is 6, so that is 2n plus 6. Independent practice. Choose the letter of your answer. Write your answer on the space provided. What is the equivalent expression of the sum of the number x and 3? So the operations you are going to use is plus. So the answer is letter A. Number 2, the phrase for less than a number y. So there is a word than, so you are going to switch the terms. So the answer is letter C, y minus 4. Number 3, which of the expression below represents the phrase the product of C and the number D? So the answer is letter B, C, D. What is the equivalent expression of the phrase the quotient of y and 5? So the operation you are going to use is divided by. Then the first term is y and the second term is 5. So y over 5, letter D. Number 5. What is the equivalent expression of the phrase the sum of twice a number w and 8? So the answer is letter A. Twice a number means 2 times w and plus 8. So 2w plus 8 is letter A. Next, we have evaluating algebraic expression. When a number is substituted for the variable in a polynomial, the polynomial takes a numerical value. Finding the value is called evaluating the polynomial. To evaluate an algebraic expression means to find the value of the expression when the variable is replaced by a given number. There are at least two steps involved in evaluating an algebraic expressions. First, replacing the variable by the given number value through substitution. Second, replacing the variable by the given number value through substitution. The second step is performing the indicated arithmetic following the order of operations. Here are the steps in simplifying the order of operations. First, simplify expressions within grouping symbols. Second, simplify powers. Third, simplify products or quotients from left to right. Then simplify sums and difference in order from left to right. Or you can always remember the word PEMDAS, parenthesis, exponent, multiplication or division, addition, and subtraction. Example, evaluate the polynomial 6x squared plus 3 when x is equal to 0, x is equal to 3, and x is equal to negative 4. When x is equal to 0, we will substitute 0 for x, then evaluate the resulting expression. From the expression 6x squared plus 3, substitute the values of x, which is 0. So 6 times 0 squared plus 3. 0 squared is 0. If we are going to multiply to 6, that is still 0. When we added by 3, the answer is 3. When x is 3, we will substitute 3 for x, then evaluate the expression. We have 6x squared plus 3. Substitute the value of x, which is 3, so the expression is 6 times 3 squared plus 3. 3 squared is 9, multiplied by 6 is 54, added by 3 is 57. When x is equal to negative 4, we will substitute negative 4 for x, then evaluate the resulting expression. We have 6x squared plus 3, substitute the value of x, which is negative 4 squared. So we have 6 times negative 4 squared plus 3. Negative 4 squared is 16, multiplied by 6 is 96, added by 3 is 99. When an expression contains more than one variable, you need a value for each variable to get the numerical value of the polynomial. Example number 2, evaluate 4x minus 3 divided by 3y minus 4 when x is equal to 1 and y is equal to negative 1. Another given, if x is equal to 2 and y is equal to 3. If we have 4x minus 3 divided by 3y minus 4, substitute the value of x and y, which are 1 and negative 1 respectively. So the given expression, we have 4 times 1 minus 3 divided by 3 times negative 1 minus 4. So 4 times 1 is 4, 3 times negative 1 is negative 3. 4 minus 3 is 1, negative 3 minus 4 is negative 7. So the answer is negative 1 over 7. What if we have 4x minus 3 divided by 3y minus 4 if x is equal to 2 and y is equal to 3? Again, substitute the values of x and y respectively. We have 4 times 2 minus 3 divided by 3 times 3 minus 4. 4 times 2 is 8 minus 3. 3 times 3 minus equals 9 minus 4. 8 minus 3 is 5. 9 minus 4 is 5. So 5 divided by 5 is 1. Multiple choice directions. To assess your learnings on this module, take this opportunity to read and answer the questions below. Write your answer on your mathematics notebook. For numbers 1 to 5, evaluate using the given values. If A is equal to 1, B is equal to 2, C is equal to 3, X is equal to negative 3, Y is equal to negative 2, and Z is equal to negative 1. Number 1, the expression is 2A plus B minus C. Then, let's substitute the values of A, B, and C. So, 2 times 1, that is 2 plus 2 is 4 minus 3 is 1. So, the answer is letter B. Number 2 expression, 4x plus 3y. So, the values of x is negative 3 and y is negative 2. So 4 times negative 3 plus 3 times negative 2. So 4 times negative 3 is negative 12 plus 3 times negative 2, that is negative 6. So the negative 12 plus negative 6 is equal to negative 18. The answer is letter A. Number 3, 10a divided by 5 minus 7b. So 10 times 1 is 10 divided by 5, that is 2, minus 7 times 2, that is 14. So 2 minus 14 is negative 12. The answer is letter A. Number 4, 3c minus 5z. So c is 3 and z is negative 1. So 3 times 3, that is 9, minus 5 times negative 1. So that is positive 5. So 9 plus 5 is 14, letter B. Number 5, the quantity of A plus B minus 24. So A is 1 and B is 3. So 1 plus 2 is 3 minus 24 is negative 21. So the answer is letter C. Thank you for listening. If you have any queries or questions, you may log on to your LCMS for the activities as well as the quizzes. If you have questions, you can contact me to my cell phone number 0930 680 829. Again, have a blessed day everyone. Stay safe.